All right, guys, we got a small titanium threading project to do right here. We've got these 4 titanium 8mm rods. These belong to one of my viewers. His name is Landon, and he is from Keswick, Virginia. And Landon had emailed me and explained to me that he has a special needs child that is autistic, and one of the things that she actually excels in is skateboard riding and scooter riding. So apparently she's got skateboards and scooters, and that's really all that I know about the story. Lana says that she doesn't communicate verbally, but she loves her skateboards and scooters. One of the problems that he's been having with her scooters and skateboards is that somehow she is breaking the axles. I don't know any more than that, but she's breaking the axles. So apparently she's out there having fun on these skateboards. I know that people that ride skateboards, they do a lot of jumps and tricks and stuff. Maybe she's doing that kind of stuff on there. But apparently he's always trying to fix the axles on these things, and he wants to try some titanium to see if it will be a little stronger than what he is using. So he asked me would I thread these rods for him. Just got to thread each end. We're gonna thread it to 5/16 24. So fine thread, 5/16 fine thread. He's going to use some lock nuts that go on the end of that thing. So what we got to do is just turn them down slightly. He only needs 8mm engagement of thread down on each end of that. So we'll have to cut each side down just slightly to 5/16 and then thread it for a 24 pitch thread on all 4 of them. Pretty simple little operation. So this is one that I've already done. This was an extra piece that he sent. He just wrote sample on it, and that's exactly what I did. Is I just went to the lathe and went ahead and I wanted to go ahead and give it a shot and make sure that it was going to work good, which it does. There's nothing wrong with it. I mean, it machines nicely. So this is just a little sample piece for me, but that's basically what we're going to be making right there. But I do need to cut them to length. We'll face the ends, make the ends look nice, and go ahead and thread it up. And I'll show you guys the threading process along the way there. Try to give you a few different shots of the threading action. Maybe try to get the camera zoomed in there tight so you can see it a little bit better on some of it. All right, so I will meet you down at the lathe. So we do have the collet chuck mounted up into the lathe headstock here, and we are running a 5/16 collet. It'll hold this 8mm rod just fine. So what we're going to do is just go ahead and face off one end of all 4 of the rods. Go ahead and get my speed set up right here. So we're going to face off all 4 ends, and then I'll go over to the bench there, blue them, and just scribe them, because we've got 2 of them at 2 different lengths that we need to make. I believe 2 at 60 and 2 at 74mm. I've got everything written down over here on the bench. So let's just get the ends faced off real quick. So what I'm going to do is, well, let's see. I was going to do something else, but I don't need to at this point. We're just going to go ahead and take this guy out. Put the next one in. And just get them all faced off real quick. All right, so yeah, 2 of them at 60, 2 of them at 74. I'm just gonna go ahead and put a little bit of this red dicum on there. We've got a metric rule right here, so just kind of line it up with the ends. We're just gonna put some of this on here so that we can kind of scribe them, and then we'll go part them off. So 60, and then these will be at 74, so somewhere about there. This is my wonderful little reed. It's the 203.5 smooth jaw vise. I love it. Love it for clamping things without marring it up with serrated jaws. So we've got the caliper set at 74. I'm just going to put a mark here on the end. This is not anything super critical on length, you know. So the plan is to just go ahead and just put a mark on there like that. We'll put it back in the lathe, and I'll take my parting blade and line it up right next to that scribe mark right there and just part it off. Part it off just a little bit proud, and then touch up that face so that it looks good again. Even that is a little overboard for what he's needing on this, but you know, I always try to make our parts be on size and look good as well. Making sure I got the right end there. I do. All right, so that's the 274, and then what did I say? Was it 60? Yep, 60 millimeter for the other two. We're going to touch up the end of this parting blade here. I'm going to reverse the lead angle on the tip of the tool there. That's all it needs. We'll take I always take a hone, a fine hone, and just hone the corners so that they're not razor sharp, but we have a nice sharp cutting edge. That's looking good right there. Let me grab my oil, cutting oil, while we part that off. I'm just going to let the pieces fall down, and I'm going to fish them out whenever I'm done. And it feels like it's a little high, so let me drop it down. There we go. A little bit high still. There we go. Now whenever I turn the ends down a little bit, I'll just go ahead and face that end out right there. All right, next quick op, we got to turn the ends down to 5/16, or actually 5 thou below that. So we're going to be turning it to 307 thousandths of an inch on each end. The ends that we parted, I'm going to go ahead and just touch those. I measured all of them, and they're all about 0.4 millimeter long, which is right where I wanted it there. All I want to do is just clean the ends up, just to make it look good with that turning tool right there. I'm going to set this indicator. Give myself about 9 millimeters of turning length right there. And we'll grab the mic and just go ahead and check it. And what I would like to do, yeah, so I actually got another 5 thousandths. right here. I'm going to set a dial indicator on this cross side just like I do whenever I'm threading. It'll be accurate to come back to every time to turn it to the diameter. Go ahead and check it with the mic. And we are at 307 right there, okay? Just go into my 0 on the dial here. It should repeat within 1/1000ths easy. Yes, we're at 307 right there. We're ready to just start doing some threading here. We're going to go ahead and knock through one. Let me get some measurements recorded, and we'll give you a little more detail of the threading action here. We've already got everything set to a 0. We are touched off. We're going to make our scratch pass and check it. That's a 5/1000 deep scratch pass, by the way. So remember what I always tell you, check your thread pitch and verify that you're cutting it right. And we're on it, 24 threads per inch right there. All right. We'll put a little bit of this Mystic cutting oil on here. And let's go ahead and make some passes across here. Now, I'm going to explain this to you. We'll go into a little more detail in a minute on the next one maybe. But I'm not even worried about where the half nuts engage. I'm just going to feed it in and just engage it. And I'll show you. This is 5/1000ths a pass right here. And on my test piece, I recorded that I went in 27.5 thousandths on the compound. What I'm going to do is go ahead, I've got my pitch mic right here, and I just want to go ahead and verify that we still have a little ways to go. Let me see, I'm making it to around 285 on your pitch diameter. I think I went a little deeper than I wanted to, but it's still fine. We are at 284. Should be just fine. We're going to be using hardware grade lock nuts on these rods here, so I'm just verifying. And that's nice. It's got a nice fit there. So I landed on the same number as my test piece. Actually, I'm sorry, I went to 28, so that's why I'm a little bit under right there. So that's pretty good. I'm going to take a, this is a smooth file that I always keep around. Real smooth file. I'm just going to knock the sharpness off the end of the threads right there, and of course that end. And that's good, right there. That should be fine. So I'm going to go ahead and flip this guy around, and I'll show you in a little more detail how I'm reading the threading dial on the lathe here. All right, so let's talk about our threading dial for a minute right here. This is probably one of the most confusing aspects of lathe work that we get in questions and comments, whether it be on YouTube videos or Instagram or Facebook. Usually anytime anybody shares a video like this, like a lot of times I'll share a little thread cutting video, and a lot of the comments is people not understanding how does the tool line up. And I always comment that that's how a lathe is engineered. That's one of the reasons that it was built, is to cut screws. It all has to do with this right here, and then the quadrant gears on the end that's rotating this, that's turning this, I mean. So we're going to be cutting a 24 pitch thread, 5/16 24, so 24 pitch. All right, and where you engage this half nut right here, this is going to be your, let me get it lined up. Where's it at? Right there. All right, so where you engage your half nuts, for those that don't understand, there's a set of split threaded nuts inside there, like clamshell, and it encapsulates, it goes around this screw right here. Whenever you engage this, it brings them in like that and catches this thread, okay? So that's disengaged, they just moved out. When you go down, they go in, catch the thread. All right, so where do you engage it? People are often confused about where you engage it. In our case, we can engage this any position we want. It doesn't matter where the line is or if it's in between the lines, okay? So, and how is that? So you have, on this machine, we have a 4-pitch lead screw, all right? This is 4 threads per inch. Our pitch that we'll be cutting is 24. So if your lead screw pitch is, your pitch is divisible by the lead screw pitch, in this case being 4, you can engage this anywhere you want. It doesn't matter what the thread pitch is, okay? So since 4, this is divisible by the thread pitch right there, we can engage it anywhere. So let's go ahead. You can see we got a little button right here, and this is what you verify where you line up, okay? So you have 4 lines, and then you have another hash mark in between that, so you have 8 marks. But you also have spaces in between that. So you actually have a total of 16 positions that you can engage on this. So we're going to be engaging it anywhere we want to, okay? You just have to verify, you have to make sure that you engage the lead screw all the way, all right? Because it will try to catch the top of the thread sometimes if you're not careful and start threading, and then you're going to be splitting your thread. So as long as I'm over here getting ready to thread, and if I push this down and I know that it engages, a lot of times you can go and feel it drop in just like that a little bit before you can cut. All right, so whenever I'm cutting these threads, I'm not going to be focused on where this line is engaging this dot right there. As long as it goes in, then I know that it's going to be cutting the proper pitch. It's going to be lining up with the helix that it needs to cut each time. Let's go just a touch further on that while we're standing here talking about that. So again, where to engage this this threading dial when you're threading. So if you're going to be cutting as we already discussed, if your thread pitch is divisible by the lead screw, you can engage this anywhere you want. It doesn't matter what line. If you're cutting an even pitch, an even number pitch that is not divisible by your lead screw, then what you want to do is land on any mark. In this case, we got 8 marks there, okay? So if you're cutting, say we're going to be cutting an 18 pitch. Let's just use that as an example. Any one of the 8 marks you can engage on, and that tool will line up every time. All right? So what if you're cutting an odd number of pitch? Let's just say 13, as in like a half 13. Maybe you're cutting a 13 pitch because you're making a shaft with a half 13 thread on it. All right, so that's an odd number. If you're going to be cutting an odd number of threads, then you need to pick 4 numbers and stick to those 4 numbers. In our case, we're going to use 1, 2, 3, or 4. All right, engage on a 1, skip that one. You can engage on a 2, a 3, or a 4. Odd pitch, 4 lines. There are some cases where you got to cut a fractional thread. A fractional thread. So I don't even know if I have any on here. Yeah, I do. I got 4.5. All right, so that's a great example. 4.5 thread, which I believe is 2 inch, I think. So if you're doing a fractional thread, it's been a while since I practiced this, but the best thing to do is pick one number and stick with it, okay? And that's what most people do to be safe, especially if you're threading a really expensive material. Just go ahead and pick one. But you're supposed to be safe by doing 180 out. So if you started with 1, you can come around here to the 3 and start it there as well. But like I said, it's better to be safe than sorry. That's what most people like to do. Mark your number one line and engage it on that one every time. But that's what a lot of people say they do just because they're unaware and unsure. They don't want to mess their part up. They just use the same number. But I'm trying to save you a lot of time from letting this thing rotate around on how to engage it properly, depending on what thread pitch you're going to be cutting. So again, we'll make a more dedicated video on this topic so that everybody can just have one dedicated video that's easily searchable that they can reference later. I'm going to go ahead and cut this next one just with you set up right here. That way you should be able to see the threading dial and the part over here at the same time. All right. And I'm going to go ahead and just verify that I'm on my line here. See, I'm over here looking because that's a habit. But what I'm going to do is just look forward and just engage it like that. And I'm using this indicator over here on the cross slide to bring me back to 0 every time. And we should still be on 24 because we did not disengage the gears over here. So we are good to go. What I want to do is just go ahead and start cutting this. This one here, put a little oil on there. I'm reading this. I'm reading this, and then I'm going to come over here. I'm just going to feel those half nuts engaged instead of looking at what line it's on. And it's lining up every time. Once you do it some and you get familiar with it, you start having a lot more confidence in what it's going to do for you. And we're going to go 27.5, and we should be on our finished pass right here. Came up to that shoulder, so I disengaged it about a half a thread late. Our nut fits on there just like it's supposed to right there. I'll even go ahead and check it with the pitch mic here and see where we're at. Right on the nose. It's right where we need to be. All right, so we'll flip that around and do it again. All right, we are ready to go. Should be it right there. it's not. It's a little bit tight. Something didn't line up right. Good go that time though. If I can get that thing to start straight. There we go. Perfect.
Oh, so pretty.
Indicator wants to stick there. That should be good right there. That's it. All right, well, there's our 4 threaded titanium studs. Everything came out great, simple, routine little lathe job right there. So I'll get these packaged up and mailed back over to Landon up in Keswick, Virginia. And he can get to work on his daughter's scooter and skateboard. Hopefully these little axles here are gonna hold up better than the ones that he has been using on there. I did not ask what material he's been using. Probably just, you know, normal carbon steel, I would suppose. But this is definitely something that he wanted to try and see if it would be a stronger material and hold up on the skateboards and the scooters. So there you go, Landon. Hopefully it's going to work out a little bit better for you. I'll get them in the mail right away and get them back to you. And hopefully you guys enjoyed this little threading video here. And as I mentioned, I'm going to plan on doing another threading video that's more dedicated to understanding threading on a manual lathe for all the people that are, you know, somewhat new to the channel, or maybe they haven't seen any of those older videos. By the way, you can go back and search for older threading videos. You might find something that you haven't seen before that you might like. So anyway, there we go. We'll see you on the next project.